Hi and welcome. In this video, we are going to see about interview preparation marathon contest 3 question, that is from strings distinct concat. Okay, so let's just read the problem and then we move forward to see its approaches. Fine. So the question says you are given a string S consisting of only lowercase English letters. You have to print the number of distinct non-empty substrings of the string that can be written as a concatenation of some string with itself. That is, it can be written as p plus p, where p is some string. So let's just see the test cases to understand what the question is trying to say. Okay, so here we have x, y, z, x, y, z, x, y, z. We need the number of substring of this string, okay, that can be written as a concatenation of the same string. So for example, if this is my substring, that is x, y, z, x, y, z, so this can be written as a concatenation of x, y, z plus x, y, z, correct? That is p plus p equals to p, fine, equals to double p. So it is nothing but x, y, z and x, y, z. Okay, so using the same string x, y, z, we are forming a particular substring. So how many such substrings are present? For example, now if we take yzx and yzx, so this is formed using yzx. Okay, if we take zxy and zxy, so it is formed using zxy. We need to find out the number of such substrings which are formed using another substring by concatenating it with itself. Okay, if we have, let's say, abc bc, abc bc, so it is formed this bc bc is formed using the single bc. So bc plus concatenate with bc gives bc bc. Okay, then if you see the next one, so it contains one more case. So it is PrepBytes. So if you just see here, the number of substrings are 3 that can be formed. So here it is nothing but prep and prep. So this is, so it is formed using prep. There is one more, there is a single this pp. So this is formed using a single string p, and then there is bytes and bytes, definitely formed using bytes. Okay, so this such cases are also possible. Fine. So now this was the problem statement. We just need to know how many such substrings can be formed. So let's discuss this with using these examples. What can be the simple approach to solve this problem? So if we think of the basic approach, so in this particular question, that is xyz test case, if for each and every substring we can check whether it can be created or not from this p plus p equals to p, this one, is it possible or not? Okay, so let's see how we can do this. So for each and every substring, if we are checking, so if we are taking this x, so can this x be formed or not? If we are just taking this y, can y be formed or not, or can xy be formed or not? Okay, similarly if we check for z, so if this is the center point, can it be formed or not? So if it is x, so is it possible to do it or not? So if we think of this x, so from this xyz is here on the right hand side and xyz is here on the left hand side. Okay, similarly if we solve abc bc, so in this case if we saw this bc, so this b is here on the right side and from its left side there is a bc. So if for each and every character, if we can find whether on the right side it can be formed or not, and on the left side the same string is present or not, then yes, we can say that the strings can be formed. So for example, in this particular case only, if we just begin, obviously if the first character is not possible because there is nothing on the left of it. So if we just begin with y, if we begin with y and check, on the left it is nothing but just x, and from right if we begin with this character, it is nothing but just one character y. Okay, so if we just go till index minus 1, and from index to the maximum length possible on the left hand side, which is just 1. Okay, so till index only. So is this possible? Are they equal? No, they are not equal. So fine, then let's move forward to z. So if we move forward to z, so its index is nothing but 2. How many maximum on the left possible? So maximum on the left possible is nothing but 2. Okay, so two characters here and two characters on the right. So from index I can check till two characters, so that means index and index plus 1 are those two characters, and from 0 till index minus 1 are the other characters. Okay, so let's start checking. So if we just check on first on the right, so it is nothing but z only. Okay, or if you want, we can check with this also. So we can check with xy and zx. We can easily access this is nothing but 0 to index minus 1, and this is index and index plus 1. Okay, are they equal? No. So now we can check for the single characters. So are yz equal? No, yz are not equal. This is left and this is right. So here also we got nothing. Let's move forward. Now we have here x is this. Okay, so here the index is nothing but 3, and if we just see the size of how many are on the left, so it is nothing but 3. This is nothing but 3. So the size on the left, it is max left, is nothing but 3. Okay, on the right also if we just see, so we have to go till maximum 3, because more than 3 substring is not possible, length substring is not possible on the left. So on the right also we have to just go for index plus 2, because why plus 2? Because 1 is already this character. So from 0 to less than 3, and from 3 to less than 6, that means from 3 to 5. Okay, we have to check. So first let's check for 1 to less than 3, so it is xyz, and from 3 to less than 6, so it is xyz. Are they both equal? Yes, they are both equal. So we just found a substring, that is xyz. And then what we can do, then check for the smaller length cases. So in this particular case we will check for xy, that is for yz, that is from 2 to less than 3, and from xy, so it is nothing but yz and xy, so they are not equal. And then for the single length cases we will check, that is for x, z and x. So obviously z and x are not equal, so only this was equal, and this xyz will be stored somewhere. Correct? So we got something, we got the first string. So similarly if we check for y, so how many? 4 at the back. So for y we have 4 at the back, so index is nothing but 4, and we got 4 at the back, max equals to 4. Okay, so obviously it is nothing but index plus 3, so this 4, index plus 3, and this 4, 0 to less than index. So let's see, so it is x, y, zx and y, z, xy. So obviously they are not equal, the substrings, so we will move forward. So in this case we will check for yzx, and in here also yzx. So yzx and yzx are actually equal, so therefore we will store yzx somewhere, and then we will simply move forward. So here it is nothing but zx, and here it is nothing but zx. Sorry, we have to move in this manner. It is zx, and here it is yz, so they are not equal. And then it is nothing but x and y, obviously they are not equal, so only yzx. So in this manner we can form. So what is the logic? Is nothing but for each and every point, for each and every index, okay, we check for the left substring, all the possible left substring with all the possible right substring. And in that case, if any substring we got is nothing but common, that is we are forming yzx like this, because the substring has to be in continuous manner. So in that case we will just simply store one of them, that is nothing but store yzx, because we want a count of how many such substrings are possible. Okay, so this is actually possible to implement easily, because we just need 2 loops and a substring method for this. Okay, one loop for obviously for I, one loop for j, that is from where we are starting. So I will be pointing to this particular character, and j will be pointing to the starting character. Okay, so j will be responsible for the substrings from j to less than I, and I will be responsible for the substring from I to less than I plus j minus 1. Okay, and then we obviously need a substring method, so to return the substring that we need each and every time we compare the substring, we will store them. So to store them we will use set. Why? Because we need distinct number of distinct substrings possible, so therefore the set is perfect for this particular scenario. We'll just store the strings in the set, and then we will count those particular strings. Okay, I hope you understood this method, that is a brute force approach for this particular question. By implementing the brute force approach, what we will be doing is we will be then just optimizing it to get accepted. Okay, so let's just see what we let's just see the implementation for this. For each and every I, what we are going to do, we are going to get the substrings present on the left and the substrings present on the right. fine, and then compare it. So let's implement this. So we are taking the string as the input and passing it into a distinct concat function. So here the first thing that we need is the length of the string. Okay, so str.size, this will give me the length of the string. Then we need a set, so unordered set that will contain string, so string, and let's call it a set. Okay, now for int I equals to 1, no need to check for 0, correct, I plus plus, because there is nothing on the left of the first index, so we will start with 1. Int, let's say size, max size equals to minimum of I comma length minus I. So what this is calculating? This is calculating the maximum size that is possible on the left hand side. Fine. So if we just see at this particular position here, so what is the index? 0, 1, 2, 3, 4, 5, 6. So 6 is the index. Okay. Length is total 9. So 9 minus 6 will give me 3. So it is saying that you do not have to go till starting position j. Okay, that is from 0, because on the right only maximum 3 substring is possible, 3 length. So you have to also check for maximum 3 substring only. So j will begin with this position. Okay, so therefore I am using that particular line to know that how much length maximum substring is possible either on the left hand side or on the right hand side, because then we will move forward in that manner. So this was that size. Now let's just calculate the starting position of j. So starting position of j is nothing but I minus size. Fine. Now for int j equals to the starting position, j less than I, j plus plus. Now for each and every this j, we will be start calculating the left and the right. Okay, so string left substring will give me str dot substring method substr from j to I minus j. Fine, and string right equals to str dot substring from I to I minus j. I to I minus j. So what is I minus j? I minus j is nothing but the length of the substring that we need in every case. Okay, so both should be equal, therefore I minus j is constant. So from j to let's say 3 length, and from I to let's say 3 length substring we want. So therefore I minus j is indicating the length of the substring that we need each and every time. Fine. So if the left equal to the right, so if they both are same, in that particular scenario we will use hash set dot insert left. Fine. So this was the, and finally we will simply return h set dot count. Okay, so h set dot size, sorry, h set dot size. So this is done, as simple as that. So what is size? Size is nothing but the number of maximum substring possible either on the left side or right side, because then we have to choose only that particular size. And starting position is, what is the starting position of j? We already know I, but what is the starting position of j? So therefore for calculating we are using this. Now from that position to less than I, we are just calculating the left substring and the right substring. Okay, so this is nothing but, and I minus j is the length of that particular substring. First we will need 3 length, then we will need 2 length. So j, if let's suppose j is equals to 0 and I equals to 3, so this is nothing but 3 length substring. Then j will increment to 1, then we will get 2 length substring, because 3 minus 1 is 2. Then j will increment to 2, then we will get 1 length substring, and so on. As you can see here, first we are always getting the larger substring. So we get first xyz, then we get yz, and yzxy, and then we get a single character. So first 3 length, 3 minus 0, then 3 minus 1, then 3 minus 2, a single character. Okay, so why we are doing this? Remember the PrepBytes? So they also have a single character right here, pp. So first we will check for prep and prep, it is fine. Then we will rep and pre, no. Then we check for ep and pr, no. And then we check for pp at the last, that is single character. So it is 4 minus 0, 4 minus 1, 4 minus 2, 4 minus 3. Okay, in prep. Correct. So therefore that particular loop is working like that. Fine. So I hope you understood this particular implementation. Okay, this will give TLE, and we can reduce it. How we can reduce it? So let's see that part. Okay, so this will definitely give TLE. Fine, because we are using a substring method, and this is also order of n. So there are actually 3, there are loop, then again a loop, and then inside also there is order of n. So we can reduce it. There is no need to check for each and every substring. Example, if it's see in this particular case, when we got xyz and xyz, we got xyz, xyz. Okay, and then after that we got yz and xy as a substring. But if we are comparing each and every character, instead of comparing the whole substring, if we compare each and every character, on the first character itself we got that no, they are not matching, so there is no need to check for other characters, so there is no need to use substring method, because at the first character we got that they are not matching. Okay, so what we are going to do is, in that implementation we are going to change, instead of using the substring method we will be comparing each and every character. If x equals to x, then we go to y. Is y equals to y, then we go to z. If they are equal, then we will insert. Then we are checking for yz and xy, so yz and xy. So in this particular case we will check if y equals to x. No, it is not, so there is no need to move further. So there is no need to actually get all the substrings that are possible. Okay, we just need to compare it by character, and if the first character is not equal, obviously the string is not equal. Okay, if the first character is equal, then we move to the second character and repeat the process. Fine. So we'll be using this part as the first optimization, that is, we do not need the substring method. And for the second optimization, what we can do is, suppose this is the string. Now as you can see, we need distinct substrings. Okay, so if this is, as you can see here, if we just check for this a, so a will be equal to a, and a will be given to the set. Fine. And then if we move forward, so it will be aa, this aa and this aa, so aa will be given to the set. Okay, then again we will be checking for aa, the single string again. Then again we start with AAA, and AAA will be given to the set, but again we will be checking for aa and aa. Okay, and again we will be checking for a and a, single a and a. So this process is repeating itself. So if we have 4a, just how much comparisons we will do, just see this, how much comparisons we will do. First we will check for 4a and 4a separately. Yes, 4a will be given to the set. Then we will check for 3a's, but remember 3a's is already done before, so we are checking it again. Then we will check for 2a's, which is already done, we are checking it again. Then we will check for single a, which is already done before. Okay, so therefore this process can be reduced. Okay, so once we found out that a particular, this will definitely be inside the set, but once we found out that this is already present in the set, okay, then we do not need to check further, okay, so because if it was present, it will be already inserted. So what we can do is, we can use count method of the set, and if this count is equal to 0, then we will insert, and if this count is not equal to 0, that means this triple is already present in the set, and in that case we will use break. So this is the second optimization. Okay, so in the first optimization we will be not using now the substring method, we will be using a loop, and in that loop we will be just checking the characters, and if we found out a character is not equal, we will simply break that loop. Okay, so therefore there is no need to, we will reduce the comparisons by a lot, we will not need each and every substring. In the second case, we will not insert each and every time, we will not even check. Okay, so if AAA is already present, then all the other substrings will not be even checked. Okay, it will simply break the J loop itself, and we will go to the I loop again. Okay, so these two are the optimizations that we will be doing in this particular same code that we have written, but with the optimizations. Okay, so let's see the implementation now. So here now we have to reduce this part, so we will not the substring, we will not using the substring, so reduce this. Fine. And then what we are going to do is, we will be converting our string into a character array for just simplicity. So char p, so this is a function that is used to convert a string into character array in C++. Okay, fine. Now we'll be using this p. So this is part is same, that we are calculating the starting position of j. Okay, that we definitely need. So now what we are going to do, we are going to have a left pointer, a right pointer. So int r equals to I. Okay, and the count. So if this count equals to I minus j, that is nothing but the length of the string that we need. Okay, if this count equals to I minus j, and when this count will be equals to I minus j, when all the characters are equal. So while L is less than I, if P of L plus plus equals to P of R plus plus, okay, in that particular case count plus plus. If this is not the case, else we will simply break, we will break the loop, and we will go to the J loop again. Okay, so when this count will be equals to I minus j, only in the cases when the substrings are equal. For example, if we just see xyz and xyz, xyz and xyz, okay, in this case we get I here, so I value is nothing but 3 and j value is nothing but 0, so I minus j is nothing but 3. So x equals to x, r is this, l is this, and r is this. So are they equal? Yes. So l will increment here, r will increment here. Are they equal? Yes. L will increment here, R will increment here. Are they equal? Yes. So count will become 3. So if this count equals to I minus j, that is nothing but the length, okay, from this position to this position, I 3 minus 0. If this equals to I minus j, then in that case we are going to insert it into our set. If it is not already inserted, we are going to insert it into our set. Fine. So in this particular case, if count equal to I minus j, okay, so we are going to insert it. So string. Now we can just simply use for just one time. So string p plus j comma count. So this is character array. Okay, we are converting that particular array to string, just that part of p plus j to the count. So we get that substring. So if s set dot count, I told you we will be using count, s equal to 0. Okay, so if this is not already present, so in the s set we are going to insert it. Set dot insert. Fine. Now if this is already present, then we are simply going to break. We are not going to repeat the whole process again. So we are going to break the j loop. Now once the j loop is break, we are going again starting with the I loop. Okay, here only while loop was breaking, that is this one. Fine. And simply then we are going to return set dot size. So this was the optimizations that we made, that we do not need every time the substring methods. Fine. We are just going to compare it character by character, and if the character is not equal, we are going to break it. So for all characters will not be checked. Fine. And if all the characters are equal, in that case we are simply checking if it is equal to the length. If it is equal to the length, then we are going to get that particular substring, and then we are going to check if it is already present in the set or not. If not present, we are going to insert it. If present, then break. This is also really important. Okay, that this also reduces many comparisons, because then again the j loop will start and the same comparisons will take place, and that is not needed. And then when you just run this, and this code will be accepted. Fine. So this was the implementation, both the implementations for the distinct concat question. Okay, thank you.